This I think is an 8,000 thick wall sticking up like 2.5 inches tall. And we machine that at hundreds of inches per minute without chatter or vibration. So what we're using is a geometry that gets rid of vibration. And so you can see here, this is the same type of cut without mirror edge, and then it's hard to see because the finishes are so shiny, but this is the same cut with mirror edge. And what is mirror edge and how are we getting rid of chatter? As we're cutting, chatter is caused by the vibration of the tool vibrating at a certain frequency and the part vibrating at another frequency. And what happens is they excite each other and they vibrate even more because the tool is taking a deeper cut than it should, then a lighter cut than it should, then it won't make contact, and it just self-excites each other, and every machinist knows what chatter sounds like. So what we're able to do is we're able to put geometry on the tool that it induces its vibration into the material. So no matter what RPM you're at, the vibration of the tool and the vibration of the part will match. So as that tooth comes around, the tooth and the tool and the part are in the same spot. So they're kind of like dancing together, so you don't get the vibration and chatter that you would normally do.
That right helix puts us in the window where it's so much easier for you to get 3 or more points of contact. And, and what does it matter? I'll show you this real quick. So we think a lot about deflection. You want a nice, smooth, stable cut. So, if I think about my end mill as a spring element sitting out there, and I have a certain length out of the holder, and I apply a certain force, I've got this nice deflection, and it's going to spring back and forth. Anytime it moves away, it's coming back, right? So if I'm tapping it as those edges are going in and out, certainly there's other things we can get into in terms of vibration and tap testing, but even at a very basic level, without going into all of that, those edges are going in and out of the cut. You're kicking it away, coming back, and that shows up on your part. So as we put more points of continuous contact in, just by that design, we let you take a lot different types of cuts. You can play around with what you want to go axial, radial, and be in a nice window to know that you're going to get that nice, smooth finish every time, even when you're being aggressive.
Right.
So,
and that's the reason why a lot of people that are machining aluminum in high velocity are really strict about tap testing their spindles before they run the part. And they tap test it because they know that they're coming in and out of the cut. So they got that frequency. So they have to match it. And they want to try to dial it in with adjusting the RPMs. But when we have 3 points of contact, at least 50% of the rotation, then that need to have a tap test is much less needed. I don't think it's nearly as important as it would be if you were running a two-foot.
Yeah.